Number 17 then, here's the graph of a function. You don't actually have its equation, but you've got these characteristic points on it. You've got where it's cutting these axes. So, from those roots, you could reconstruct the factors that produced them. So this root here must have come from an x plus 2, and this root here must have come from just an x minus 0. But this is a tangent point. It's not one clean cut, if you like, there's a double cut there, so that should have been squared. Whereas that one is a clean cut, there'd just be a single x minus 0, which you can just write as x. That must have been the factorisation that produced those roots. But as far as the equation is concerned, there might have been a common factor that came out first of all, when you went through the process of factorising it. So we've got this k here. You can find that k if there's some other point on it. There's no point in putting the 0 or the negative 2 in, because it'll just knock out those terms, and when they disappear, they drag k away with it. No, I've got a 0.13. Put 3 for y, because it's a coordinate equation. Y stands for the y coordinate of any point on it. X is the x coordinate of any point on it. X is 1. So k times 1 plus 2 squared. Well, 1 plus 2 is 3. 3 squared is 9. So that's 9k. So k must be, take the 9 across and divide, must be 1/3. You knew it had to be positive anyway, because that's a positive cubic graph that goes up like this. So that means comparing the equation for the equation, it says what are the values of a and k? Well, the a was a 2 and the k was 1/3. So which ones I've got those? A is 2, k is 1/3, that's C. Number 18 then. Well, what have you got here? You've got a function of a function, you have to find the derivative. Now notice with this one, chain rule if you like, function of a function, this time what's acting on the bracket in a function is a trig term rather than a power. You don't consider it as both together. You've got a trig term acting on it, so the outside would be sine of something we differentiate to cos of that thing. And if the thing itself that it's acting on isn't just x, then you would then multiply by the derivative of the inside, which then provides this next link in the chain, as they would say. Now the derivative of that would be 2x, and 0 would just be 2x. So I've got 2x cos x squared minus 3, which is D. So, number 19 then, a quadratic inequation. You have to be careful with these inequations if this isn't just a simple linear term like that. You can't go swapping sides and so on. What you would have to do here is consider the graph of this. That's a picture of all the answers, because you want to know which values of x give answers which are greater than 0. Now that's an upside down parabola. A picture of those answers would look like this. And there'll be an up and a down and above and below 0 if it ever crosses the axis. You're looking for the part above, so it's going to be this portion here. The solution to this will be between two numbers. It'll be between the two roots of the equation for that. But another way of doing that is just to reverse all of that. I prefer factorising something with a positive x squared, so I'll flip all the signs, multiply them by -1. So I've got 3x squared plus 2x minus 1, and that will change as well to less than 0. Now it's the same thing, because this time the graph I'm considering is a correct way round parabola, but I'm wanting the part below, which of course is still between the roots. So now I can factorise this part. It must be 3x and x, it must be 1 and 1. The positive middle term means the larger product's positive. The negative at the end means they must produce opposite signs, so that must be that, a negative. And then my two solutions are for the roots, x equals 1/3 or x equals -1. So it's cutting at -1 and it's cutting at 1/3. And it will be below 0 if you're between these. If x is less than the third and greater than the -1. So that's B. Number 20, here's a log graph here. The graph of log 3y is plotted against x and it forms a straight line. Now that means you can immediately write down the connection between them because it's linear. You know, linear equations for certain. You know that the vertical variable, which is log 3y, is going to be mx plus c. So it'll be the gradient 2 times this variable, which is just x, but plus 0 because it passes through the origin. And if it wants to express y in terms of x, you just need to get rid of log base 3. So y is going to be, instead of log base 3, its inverse would be 3 to the power 2x. You notice that isn't there, because you could split that. That's the same as 3 squared to the power x. The power of a power gives that product. And 3 squared is 9, so it's 9 to the power x. And there it is. That's answer D.